In this video, I will demonstrate how to separate dichloromethane and ethyl acetate using a simple distillation. Before you begin your distillation, it is important to note the atmospheric or barometric pressure during the time of your distillation. Boiling points are the temperature at which the vapor pressure of a liquid being boiled is the same as the applied or atmospheric pressure. As a result, the atmospheric pressure on any given day will cause slight changes to the temperature which a substance boils at. Normal boiling is exactly 1 atmosphere of pressure, or 760 millimeters of mercury. The actual atmospheric pressure is almost never exactly 1 atmosphere, but if the actual pressure is known, the normal boiling point of a given substance can be calculated from an observed boiling point. Here we have a simple distillation apparatus. Some important things to note are: the distance between the Bunsen burner and your ceramic plate should be about 3 inches. This ensures that your round bottom flask is properly heated, but that it does not heat up too quickly. In the round bottom flask is where we will have our mixture of organic compounds that we want to distill. Inside you can see boiling trips. These ensure that the substance will boil evenly. The round bottom flask is held firmly in the clamp, but not too tight, so as not to break the flask. The thermometer is positioned so that the bulb of the thermometer is just below the opening of the condenser. This is so that vapors must check in with the thermometer before condensing. As they evaporate and travel up the apparatus, they will first pass the bulb of the thermometer and then into the condensing tube. This ensures that an accurate temperature is measured. The condenser is held into place by 2 elastic bands. This ensures that it will not slide off, and so prevents unnecessary breakage. The water in the condenser flows in the tube from the bottom, fills up the condenser, and then flows out the top. Ensure that all ground glass joints are lubricated with vacuum grease. This ensures that they are properly lubricated and will not damage the glass, and also provides a proper seal. In order to separate the 2 liquids, we will begin by heating the solution with the Bunsen burner. As the solution heats up, low boiling impurities may evaporate first. We want to capture these in a slop bucket. Once the solution heats up to about 39.8 degrees Celsius, which is the boiling point of dichloromethane, our lower boiling solvent, then we will want to switch out the slop bucket for an Erlenmeyer flask. The tapered edges of the Erlenmeyer flask ensure that our solution will not evaporate during this distillation process. Once the expected volume, approximately, of your solution has been collected in the Erlenmeyer flask, and if there is a sudden increase or decrease in the temperature, the Erlenmeyer flask can be removed and replaced with the slop bucket. We will want to continue to heat the solution in order to boil off any solvent left and any higher boiling impurities. The boiling point of ethyl acetate, or other compound in solution we are trying to distill, is about 77.1 degrees Celsius. So we can heat the solution until it reaches between 50 and 60 degrees Celsius. This will remove all the solvent and ensure that none of the solute will evaporate. The 2 solutions have now been separated. If the purity of the substance is separated, we can use infrared spectroscopy and gas chromatography. IR spectroscopy will give an IR spectrum for the substance. If there are absorptions in the spectra other than those for the compound being tested, it indicates that there may be impurities. Gas chromatography can also be used. Impurity can be assessed based on the number of peaks and the area underneath the peak on the chromatogram. The higher the peak, the more pure the substance.